there, method students. This video we're just going to go through this last exam question from 15A. So this question is a calculator allowed question, it's multiple choice, and it says the continuous random variable x has a probability density function given by this hybrid function that we're kind of now getting used to seeing. F of x equals cos of 2x over this domain here, or it equals 0 elsewhere. So remember that that's just showing us that, like, other than this part, so this is where all the area under the function will exist. Everything else is just like a horizontal line on the x-axis with no area underneath it. This question is a little bit backwards though, because this one says the value of a such that the probability that x is less than a is equal to 0.25 is closest to. So just to kind of get a good look at what's going on here, what I've done is I've typed into the calculator the function and I've restricted the domain so that we can kind of get the graph here. And this graph is showing us the function, and remember that and it's not drawn on the calculator here, but there would really just be horizontal lines along the x-axis on either side of this this curve. So we know that this full area will be equal to 1 because that's our full that's the whole distribution of this variable. If we kind of like sketch this out, and I've done this on the page here, you can kind of see or identify what this question is asking us to do. It's kind of saying, well, we've got this value a such that the area under the function that's less than x equals a, this area will equal 0.25. So in other words, the area between this lower terminal where the function actually starts and this number a will equal 0.25. Our job is to find that value of a. So we obviously know that it has to be between 3 pi on 4 and 5 pi on 4, but from our sketch, because this is only 25% of the full area, we kind of know that a is a bit closer to 3 pi on 4 than it is to 5 pi on 4. Obviously, we can't just say roughly where it is, we actually have to find the precise value. And so on the calculator, the way we can do that is we're really essentially saying, well, let's come up with an expression for this area, which we can do. We know that let's do that. The integral, so that area would be represented by the integral from 3 pi on 4. It's a bit lazy actually, I'll copy it from there, up to a. All right, so the integral of the function cos of 2x with respect to x. So what you're kind of noticing here, hopefully, is that this is one of those questions, we did lots of them in integration, where the terminal is the unknown number, and you're actually, I guess, what the area equals. You're trying to work backwards and find the terminal. So we know that all this is equal to 0.25, not negative 2.5, 0.25, 0.25. Our job is to solve for a. So let's go back to the start there and go action advance solve at the beginning. And because we're solving for a, we need to put comma a at the end, because we're not solving for x. And the other thing that we're going to want to do, so if I kind of solve this now in decimal mode, we want decimal answers and radians. We're getting the general solution. That's because I didn't restrict the domain on this, because this is giving me a general solution with lots of possible values for a. We know the restriction on a is that it's between 3 pi on 4 and 5 pi on 4. So what we can do is put at the end of the calculation here, we can put this, math 3, given that 3 pi on 4 is less than or equal to a, and a is less than or equal to 5 pi on 4. And that should hopefully give us, wrong argument type, great. That's not what I was hoping for. Do I need to close the bracket? Yeah, I just need to close that bracket. That gives us a value of a that's between 3 pi on 4 and 5 pi on 4, and hopefully that's going to match up to one of the options here. What did it say? It said a equals 2.879, and so a is closest to, 2.88. Okay, so a bit of a backwards one, but hopefully even just like kind of going through that process of visualizing this graph is helping you consolidate this whole idea of how we're using areas to find probabilities, or in this case, kind of working backwards, we knew the probability and we were trying to find a terminal.